Okay, welcome back, and now we're going to do a couple of examples. And so here we go. So we've got a function over a closed interval, and we want to find the absolute maximum and absolute minimum. So the first thing I'm going to do is I'm going to evaluate at the endpoints, evaluate the function. So f of 1 equals and f of 3 equals. So f of 1 is going to equal 0. Okay, right? So this is going to equal 0. And then f of 3 is going to equal negative 9 plus 9, which is 0. So that's going to equal negative 2. And then what we're going to do is we're going to find the critical values, right? So that's step 2. So we need to find the derivative function. So the derivative of f of x is equal to negative 2x plus 3. And we're going to set that equal to 0, and that tells us what? That x equals 3/2 is a critical point. Okay? And so what we're going to do is then we're going to evaluate f of x at 3/2. So f of 3, oops. So f of 3/2 is going to equal, well, it's going to equal negative 9/2 plus, oh, not 9/2, negative 9/4 plus 3 times 3/2, which is 9/2, which is the same as 18/4. And then we're going to have minus 2, which is the same as 8/4. And so that's going to give us what? That's going to give us 1/4. All right, so now we just compare the values. Now looking at all the values, 1/4, negative 2, and 0, we can see that 1/4 is going to be the absolute maximum, and negative 2 is going to be the absolute minimum. Okay? Now, let's do the second one. Okay? So the second one, I'm going to set up a table. Again, I'm a fan of tables too, so I'm just going to set up a table so I can organize things better. So I'm going to have my x values, f of x, and my extrema. Again, you could set it a little differently. So now, what I'm going to do is I need to test the point. So let's go again. Let's start with the endpoints. So f of 0 and f of 2. Now here, my f of x is x squared minus 3x, okay, to the 2/3. So x squared minus 3x to the 2/3 over 0 to 2. So now we plug in 0 and we get 0. So f of 0 is 0. If we plug in 2, we get what? We get 4 minus, well, this is 3 times what? This is going to be 3 times, well, we're going to stick in 2, and we get 2 squared, right? 2 squared is 4, so we get the cube root of 4, right? Just want to make sure I have this written down right. Yes. Just want to make sure I have the problem written down right. So this would be 2, so 2 squared, right? 2 squared is 4, and then we're going to take the cube root of 4. So this is going to be the cube root of 4. Okay. And so this is going to be approximately equal to, now that one we're going to have to get our calculator. And we get negative 0.762. Okay, so now I'm going to write those down here. So we got 0, 2, f of 0 is 0, f of 2 is negative 0.762. And now we're going to find the critical values, right? So that's the step 2. So now we got to find f prime of x. Now f prime of x is 2x minus 3 times the derivative of this. So this is going to be 3 times 2/3, which is 2. And then we're going to have x, and we're going to subtract 1. So in this case, we're going to subtract 3 over 3 from this, which is going to give us a negative 1/3. So this is going to give us x to the negative 1/3, right? So let me just double check. So bring this down. We're going to get 3 times 2/3, which is 2. And then we're going to reduce the exponent by 1. So we're going to subtract 3 over 3, which is going to leave us negative 1/3. Okay, so then this, let's simplify this even further because I don't want negative exponents, right? We don't want negative exponents here. So this is going to be 2x minus 2 over x to the 1/3. Now I want to make this into a rational expression, so I'm going to multiply the top and the bottom by x to the 1/3, and so that's going to give us 2x, let's see here, to the 4/3 minus 2 over x to the 1/3. Okay, so now we're going to set this thing equal to 0, right? And see what values of x are going to give us 0. And so if we take the numerator alone and we set this equal to 0, because that's the only time this fraction is going to be equal to 0, well, we get, if we solve this, we get x to the 4/3 is equal to 1. And the only time that x to the 4/3 is going to equal 1 is if x is 1. So that's going to be one of the critical values. So x equals 1 is another critical value. That's the only value that will make it 0. Now, what about undefined? Well, if x is 0, we get it undefined. So that's another critical value that we need to test. Okay? But we already tested 0. Right? So we don't have to do this one again. We already got it. So now we just have to evaluate 1. Well, 1 is going to give us what? It's going to give us 1 here and 3 here. So 1 minus 3 is a negative 2. Right? So now, at this point, we evaluate the functions. Right? So based on these values, we compare. So negative 2 is going to be the absolute minimum. And then 0 is the absolute maximum. And that's it. Have a great day.